Hello everyone, welcome to my YouTube channel. Today in this video we will be learning about the number system, which is one of the major topic in a mathematics arithmetic section. And number system is one of the most complex thing to be understood in arithmetic section because it is not well taught to the students. Although it is very easy, but the only thing that lies is a little bit of logic and some little bit of details that we need to understand in this video. And sometimes the teacher misses out on the very basic details what a number system contains. So let us understand that what kind of numbers are there in our mathematics section. And real numbers, and the second, well, this we will study in some other section. Today we're going to learn more about real numbers. Numbers can be only of two types. Either it can be rational number, or irrational number. Okay, this is a short form to write the numbers. Okay, now what is rational and irrational? In English, rational meaning logic or logical. Somebody who gives logic is known as a rational person. Somebody who talks very illogical is known as irrational person. Irrational means illogical. Well, this is the literal meaning of rational and irrational, but we won't go on the literal meaning. But somehow the name came from the logical and illogical numbers. So rational numbers are those numbers which can be further subdivided into, okay, see this is very important, fraction and integers. Now if you haven't gone through the integers, and if you haven't gone through the integers chapter, you can go through that video, and the description is in the link of this integers, and you can click on that link and you can directly go on to that video of integers. Okay, so right now we'll focus on to fraction and integers. Now fraction can be of two types: terminating decimal and okay, I'll move forward. Here it is, non-terminating. I will give you example, don't worry about it. Non-terminating but recurring. I will explain everything to you, don't worry. But recurring means which occurs repeatedly. Okay, but if you have not gone through integers, please go through that video. I have explained everything in that video. Integers can be of three types: negative, 0 and positive. Okay, and irrational will be only of non-terminating. My handwriting is not so good, so just apologies for that. Non-terminating and non-recurring. Okay, now I will give example of all these things, but let us understand what are real numbers in reality. Okay, so the simple definition of real number is a very simple definition, and you must not memorize it. It's very simple. Anything that can be represented on number line from 0 to minus infinity to plus infinity, anything that can be represented on a number line is a real number. That can be represented on number line, this is number line, is simple real number. Now integers, yes, we can represent it. Very nice. Now you might ask me question, where to represent the fraction? Okay, let us zoom a bit. The best part of this tab is like, or teaching on a tab is like, you can actually zoom and you can actually show. So here we can actually show 0.5 also. Now if I zoom a little bit more, I can actually represent 0.61235 also, if this is 0.6. So all these numbers, the fraction, integer, all these numbers can be actually represented on a number line. I will make it thicker a bit. Yeah, 3. Okay, so anything that can be represented on a number line is a real number. Now let us move on to the rational number. Okay, rational number is something which is of p by q form, where q is not equal to 0, and both and what actually the teachers misses out on, teachers while teaching misses out on, is they don't tell you that this rational number have a form p by q where q is not equal to 0, because whenever the denominator will become 0, that number converts to infinity. Okay, I'll tell you why it converts to infinity. There's another chapter, there's another video lecture upon why a number converts to infinity. So that's another thing, but q cannot be 0. That means denominator should not be 0. I got it. So p is numerator and q is denominator. But what they miss out on, the teachers while teaching miss out on, they never tell you, and even my teachers didn't tell me, and that's why there's a problem in understanding the rational and irrational. My teachers also never told me that p and q both should be an integer. Oh my god, integers. So if any number that can be represented by p by q form, okay, and p and q both are integers, then only that number can be considered as a rational number, remember. So that's why let us understand a rational number in detail now. Rational number is of two types: fraction and integer. We have already discussed about this one, so we'll not discuss in this particular video about this one. We will not discuss. What we will discuss about is this one. Let us concentrate on the fraction part. So let us talk about fraction. So the fraction can be terminating decimal and non-terminating decimal, but recurring. That means there will be a pattern. Okay, let us understand terminating. What is terminating decimal? Just sit back and relax. You don't have to take a paper out, you don't have to worry about anything. Just sit back and just keep listening to me and you'll get everything in your brain, right? What is terminating? Any number which 1 by 5, when I divide it, it will come 0.2. That's it. That means it ends at 2, at one position. Okay, right? There's nothing called 2, 1, 5, 6, 7 and it keeps going on. No, 1 by 5 is simply 0.2. Okay, when you divide 1 by 5, so 1 cannot be divided by 5 since 5 is greater than 1, so we put a decimal and automatically the 0 comes, and 5 2s are 10. So whenever you put a decimal, there's a 0 comes there automatically, and then you can divide. So the answer becomes 0.2. Now this is terminating. 1 by 8. Okay, let us divide 1 by 8. Since 1 is smaller than 8, so again we will have to put a decimal, that becomes 10. 8 1 times 8, 2 8 2 8s are 16, 4, and since there's a decimal already, the 0 will appear here. 8 5s are 40. 8 5s are 40. That means this is also a terminating one. So anything that ends after decimal, after 2 or 3 places or 4 places or 5 places, but it has to end, right? That's known as terminating. Terminate means terminate. The word terminate in English, it means stop. So it has to stop somewhere, right? So it did stop at 5 and the third place of decimal. This is known as second place of decimal. This is known as first place of decimal, and it stops. That's why terminating ones are fractions, and it is a real number, okay. Now let us go on to non-terminating but recurring or whatever makes you happy. Okay, now what is the example of this one? The best example is 2 by 3. Okay, can you see, as I told you, it has to be p by q form, and p and q both has to be integers. So 1 and 5 are integers. You see, 2 and 3, remember, 2 and 3 both are integers. Hence 2 by 3 is actually a rational number. But how? It's non-terminating. So whenever you will divide 2 by 3, again 2 is smaller than 3, so we'll put a decimal. 20, 3, 6, 18, 2, 6, 18, 2, 6, 18, and it will keep going on. So this is non-terminating. It will not terminate at a particular number. It will keep going on. But the point is it recurring? Yes, it is recurring. 6, 6, 6, 6. There's a pattern, right? There's a pattern. So we don't write like this. We don't keep writing like to infinity, because it will go up to infinity. And that's why it's never equal. So whenever something is not proper, we are not getting the answer, but it goes to infinity. So we don't write equal. We write almost equal to. So almost equal to 0.6666666. So we can write this as 0.6 recurring, or this can be also written as 0.66 recurring, or this can be also written as 666 recurring. So whenever you give the recurring sign over anything, that means it will keep appearing after that in pairs. So if you have given only one, so this will keep occurring like 6666. So anything is okay, right? So this is non-terminating. Why? Because it's not terminating at all, but it's recurring, right? I can see the 66 is appearing again and again. That's why this is also a fraction, and this is also a rational number. Now the point is, you may ask me a question, Mr. Abhishek, whether I can plot this on a real number line. Yes, we can plot this on a number line. So let us make a number line, and let us zoom a bit. Let us make one here, and I have further zoom it. Okay, somewhere in midway there will be 0.5, and somewhere here it will be 0.6, and somewhere here it will be 0.7. Now further we can more zoom it, and we can say that here is 0.65, and here it is 0.666666. so this particular point is 0.6, and it can be represented on a number line. Hence 2 by 3 is actually a real number. Okay, 2 by 3 is actually a real number. Now let us understand what is irrational number. The definition was simple. I tell you, the definition is, it should be non-terminating, of course, just like the 5 minutes ago what we saw. It should be non-terminating, but non-recurring also. I mean, there's no particular pattern coming after the decimal. So it will be a non-terminating first of all. Second, it will be non-recurring also, like root 2. So if you see the value of root 2, it will be like 1.414 and something 205 something. I don't remember exactly because it's been a long time now. But it will never ever terminate. That means it will go up to infinity. If you keep doing it, it will go up to infinity, but it doesn't even have a pattern. If you can see, there's a 414. So if there was a 414, again 414, again 414, okay, I understand that this is actually a pattern. So I can write 414 recurring. That means 414 is occurring all the time. But the point is here, all the number keeps changing. So that means there's no such pattern in which we can actually express this. Hence, it is an irrational number. Now, you can ask me, okay, Abhishek, we can also write root 2 in a p by q form, right? Just like the way you explained a rational number. So root 2 can be written as root 2 by 1. Of course, it can be written as root 2 by 1. The point is, I told you one more criteria. The criteria should be, if you remember, this has to be, p has to be integer. Very nice. You guessed it right. This has to be integer. This has to be integer as well. So 1 is integer. I accept. But root 2 is not an integer. It's not an integer. That's why root 2 is not a rational number. Root 2 is not a rational number. It is an irrational number. It is an irrational number. Hence, root 2, root 3, root 5, root 6, root 7, all those numbers whose proper square roots are not, like, you cannot write 4, root 4. Root 4 will be 2. And this is an integer. And 4 is an integer. Of course, this is also integer, but 2 is an integer. So it is, the square root of 4 is directly comes 2. That's why root 4 is not an irrational number. Is not an irrational number. What is an irrational number? Root 5. So if you keep doing the value, it will also come like root 5 will be somewhat 2.2 or I don't know. It will keep coming like it will just keep recurring, right? Until you have root 11, root 12, root 13, root 14, in fact, root 15 also. But again, root 16, no. Root 16 cannot be. Why? Because root 16 has a proper root, square root. That means 4. If you square 4, it will come exactly 16. So hence, irrational number are those number which cannot be, which can be written as p by q, but p and q will not be integer. So hence, if it is not an integer, both the numerator and denominator has to be integer, right? And hence, it is an irrational number. But certainly this number can be represented on number line. Can be represented on number line. Hence, it is a real number. Hence, it is a real number. Okay. So the best part of this laser is that, yeah, it diminishes and it disappears. So I can do anything. So here is a super explanation of all the numbers in a real number. And hence, this concludes the entire section of real numbers. Hope you understand it. If you liked the content, please hit the like button and subscribe my channel and spread as much as you can. And if it is helping your friend or family members, that you can share the channel as much as you can. Thank you so much for watching this video. And I am loving the support that you people are giving to me. Thank you so much.